you know, let's explore it. It's a heuristic. I don't deny that animals, anything can be heuristic. But the problem revolves around what is prediction. What is predicted? And it's not analysis. It's not a casual relationship. It has to be causal.
Well, perhaps I could just interject. The original question was on predictability. I would direct you and perhaps other members of the audience who are interested to an article in Nature Reviews Drug Discovery 2003 by Abramowitz from Lexicon Genetics. What they did was take the 100 most popular clinically prescribed drugs, and they did mouse knockout studies in which you selectively delete a gene, and they asked whether the phenotype of that mouse knockout would have in fact been predictive of a model to develop that drug. And their conclusion, you can study the conclusions as you wish, was that it would. So they would have argued, I suspect, for predictability. Any other further? You had one question. I'm looking at different questions. I'll give you the microphone to be easier.
You had stated in your presentation that humans die from medical research or drugs as a result of the human or the animal models that they use. But wouldn't that be able to be flipped easily, whereas if there were no animal models, then more humans could also die due to that?
Yes, thanks. I'll show my age and say that's the $60,000 question. There used to be a game show that was called that. $64,000 question. There you go. Right, that's what I'm arguing. I am not arguing that animals never get it right. I mean, that'd be great, because then, you know, if it caused cancer in an animal, it'd be safe and nuts. What I'm arguing is that they get it wrong more often than they get it right. And it's not black and white. It's not right, wrong. What it is it's misleading. I'll give you one example of that. In the 1980s, we knew that HIV was in the French blood bank. Okay? The HIV-tainted blood was being given to French citizens. The French government decided they weren't going to do anything about that because they knew that when HIV was given to monkeys and chimpanzees, it was safe. So the mode of transmission at that time of HIV had not been worked out yet. The result of reasoning from the animal model to the human was that about, I forget the exact number, 8,000 French people are now dead because they did come down with HIV, then AIDS, and then they died. So I think we have huge amounts of empirical data supporting the fact that animal models are flat out dangerous. Now, if you're going to say that animal models work, first you have to explain that in terms of evolutionary and developmental biology. You have to give me a theory why it should work. You can't just use isolated examples where animals and humans agreed.
But that's what you're doing in the same respect. You're giving isolated examples.
No, that whole first lecture was one long, boring theoretical science lecture.
And I agree with science, but I don't agree with what you're saying.
That's your prerogative. But when you accuse me of not just being up here presenting anecdotal data, I fail to see how that first 35 minutes contained a lot of empirical data, much less anecdotal. I mean, that was complexity theory, Evo, Devo, and so on and so on. And look, this is cutting-edge stuff. You've got to know about Evo, Devo. You've got to know about complexity theory. You've got to know how all these things interact and relate. And if you don't know that, that's going to be problematic in terms of my theory. But the first 30 minutes of my lecture was theory. It wasn't even empirical.
Here we go again. The French, when the French prevented, well, let me back up a second. This representation of why the hemophiliac patients in France got infected with HIV is false. The French did not allow, let me back up. The United States had marketed a test for HIV to make the blood supply safe. It was used in the United States and other countries. France would not allow it because its own company, the Pasteur pharmaceutical company, was working on one, and they asked the government to keep it out. They knew that you can get HIV infection from blood supply because it was already marketed in the United States and other countries, a test to prevent it. So this is just another misrepresentation. Page 81, Doctor, on his specious science, which is appropriately named, He says that while animal-based nutrition research typifies the ineffectiveness of animal model protocols, for instance, the need for vitamins A, D, and nicotinic acid, so powerful in maintaining immunity, was discovered in humans. No, it wasn't. All three vitamins were discovered with vitamin A dogs, mice, and dogs. You know what is really dangerous? Spurious science, false science, science that misleads and prevent us from finding more effective treatments.
Questions or comments? We will take this question and one more question.
I was just wondering how, if Dr. Greek thought it was ethical, like how exactly you would give the drugs to the human population, what tests would need to be conducted if the animals aren't reliable, and if it's ethical to do that.
Thank you. That's a good question. Drug testing is actually easy. To begin with, I would do the same things that are being done now, which is a lot of in silico modeling, in vitro studies, and so on and so forth. Now, there are a lot of tests that drug companies could do at that stage that they don't do. Okay, and there's a movement within the drug companies themselves to do more bench work before the drug has ever progressed along. Second of all, I would skip the animal tests, again, because the animal tests don't give you useful data. Now, if they give you useful data, then fine, use them. But again, if you read the books, look up the references, and so on and so forth, even the drug company today, in the journal, Nature Review Drug Discovery, is coming out almost every issue and saying it doesn't work. Okay? I mean, I'll take their word for it. And the other thing that I would do is going to cost the drug companies a lot more money, and they don't want to do this. And number one, when I exposed a patient or a volunteer in phase 1 human clinical trials, I'd use microdosing, spectroscopy, and PET scanning. And there's a really nice article, again, in the same journal, Nature Review Drug Discovery, a couple of years ago, that outlines how that should be done. And the last thing that I would do is I would increase the number of clinical trials. I would make drug companies actually do tens of thousands. And I would also make them broader and longer, okay? And you can segue from, if in year 1, if the drug looks promising, you can release it to some people in the population. And then you can release it to more and more and more. But that's going to cut profits, okay? And that'll never happen.
That may be the first thing I agree with Dr. Greek about, is that we need to slow down the dissemination of drugs once they've been approved. It's just ridiculous what's happening. But I disagree with what he said, that drug companies want to do animal research. In fact, drug companies do not want to do almost any of these precautionary, slow, methodic studies. As a matter of fact, they're pressuring the FDA, and the FDA has actually put forth, this is hard to believe, on behalf of the drug companies, they have put forth a proposal that they will allow drug companies to test new drugs abroad among the developing nations without abiding by the Declaration of Helsinki. Look, the pharmaceutical companies are not doing animal testing because they want to. And quoting one or two drug company representatives saying, gee, we don't want to do animal studies, that's not good enough science to show that you don't need animal research.
Perhaps worth also noting that the Environmental Protection Agency decided not to go ahead with its decision to study the toxicity of insecticides in children. They withdrew that decision.
But that was a political decision, that was a scientific.
Well, it was a political decision for both, I think. One more question.
Thank you. I want to believe here that science kind of accommodates some level of false positive or false negative. That's when we talk about probability. Okay, my question in that regard to Dr. Gray is, could you kind of give us an idea of gain, what gain are we going to make if we stop animal experimentation, in terms of drug development, either gain in time, gain in we being able to reduce the false positive or false negative that we are coping with now. And also to Mr. Skolnick, I would appreciate if you could also tell us what we will lose if we stop animal experimentation in terms of, positive, false positive or false negative. Thank you.
Sure, I'll make this real quick because we're running out of time. What would you gain by eliminating animal testing? I'll quote the National Cancer Institute, Science, 1997. We've lost cures for cancer because they didn't work in mice. Okay, period. And I will also direct you to the drug recalls of late, Vioxx, Celebrex, and so on and so forth, that animal testing did not prevent those drugs from coming on the market. Now, the fallacy in this, we don't use animals to predict what's going to happen to humans, is this. The reason that drug companies have historically been able to do very abbreviated clinical trials, when they should be doing longer and broader clinical trials, is they had sold to the American public and to the FDA and to Congress, oh, well, we tested it on animals, so we already know it's safe, so we only need to test on a couple thousand humans. That's the dirty little secret that they don't want you to know.
So what was the question for me? Can you repeat your question, please?
What would you lose if you did not do anything?
You would lose a very valuable tool for gaining many important insights into how the animals, including humans, work, how chemicals interact with genes, how genes work. It's a valuable research tool to give